Okay, so for this next one, we're looking at Zachary, and he's trying to fit a cord of firewood, which is 128 cubic feet. So that would be a volume, into 3 different boxes, storage boxes, that measure 2 by 3 by 4. So the question is, does he have enough space to order a full cord of firewood? So I'm going to start by just drawing myself an image of like these boxes that are 2 by 3 by 4. So I've got 3 of them. So really what I'm trying to see is, does this 128 cubic feet of firewood fit in to the volume of these boxes? So what I'm going to do first is I'm going to find the volume of this box. So the volume is equal to the area of the base times the lateral height. In this case, my base is 3 by 4 and my height is 2. So the volume of one of these boxes is going to be 24 cubic feet. Okay, so if we only had one of these boxes, of course 128 wouldn't fit in, but we have 3 of them. So I'm going to multiply 24 by 3, which gives me 72 cubic feet of storage. So the question is, does Zachary have enough storage boxes to fit a full cord? The answer is no, because he needs at least, so he has 72 feet, he needs at least 128 cubic feet to fit him in. So for this next question, it's asking how many storage boxes would we need to fit a full cord. So if 3 storage boxes gave us 72 feet, that means that 4 storage boxes would give us, so 4 would give us 96 cubic feet. 5 would give us 120 cubic feet, so we're still not there. So we would need at least 6, because that'd give us 144 cubic feet, which would be a little bit more than the 128 cubic feet that we need. So we need at least 6 boxes. All right, for this next one, it's asking us to find the volume of a pyramid. So I'm going to initially here write down the formula for a volume of a pyramid, which is the area of the base times the lateral height divided by 3. Okay, so really in order to figure this one out, I need to know what my area of my base is. So it's a triangle, so I'm going to highlight that base, and then I'm going to find it as 1/2 times base times height. So the area is going to be 1/2 times 5 times 12. So the area of this base, it looks like it's 30 feet squared. Okay, so now in my volume formula up here, I can really just substitute in 30 from the area of my base, and I can multiply that by my height of 6, because the height of this pyramid is 6, and then divide those by 3, which I believe would end up giving me 60 cubic centimeters. Next up, we're considering the square pyramid with height h feet and each side of the base m feet. The altitude meets the square base at the intersection of the 2 diagonals. So write an expression that gives the volume of the pyramid in terms of h and m. So we're not using numbers here, we're using letters to represent numbers. I still need my volume formula for a pyramid, which is the area of the base times the height divided by 3. So in this case, the area of my base is going to be m times m, or you could say m squared. So b is going to be m squared, capital B. Okay, so next up, let's find my height. So height, they're just considering here the capital H. So my height is just capital H. So if I write this in terms of m squared and h, I would really have to write this as, m squared times capital H divided by 3. So my volume would just be m squared times h over 3. So next up we have Britta. She designed a crystal glass sculpture. Part of the piece is the shape of a large rectangular pentagonal pyramid. Okay, the apothem of the base measures 27.5. Okay, so this A down here, this little A, that is 27.5 centimeters. Okay, so if I want to find the volume of this thing, okay, so find the volume of the pyramid-shaped piece of the sculpture, I would have to use the volume of a pyramid, which is the area of the base times the lateral height divided by 3. So the area of my base in this case, I'm going to use the formula for a regular polygon, 1/2 times the apothem times the perimeter. So my apothem is 27.5, And my perimeter is going to be 40 plus 40 plus 40 plus 40 plus 40, or 40 times 5, which is going to end up giving me 200. So the area of this base is going to be 1/2 times 27.5 times 200, which is going to be 2,750, it looks like square inches, or square centimeters. Okay, so in my formula here, to find the volume, I know that the area of the base is 2,750. I know that my height is 30. It's given to me in the picture, and I'm going to divide that all by 3. So if I do that calculation, the volume is going to end up equaling 27,500 cubic centimeters. So then the next question, it's telling us that, each gram of this sculpture weighs 2.85 per cubic centimeter. So if we know how many cubic centimeters are in it, which we do because we just found it, 27,500, and we multiply that by each gram, so 2.85, we'll end up getting the weight, which is going to be 78,375 grams. All right, so next up we have a triangular pyramid, and it's got a volume of 180 cubic centimeters and a height of 12. We need to find the length of a side of its base. Okay, so I'm going to start with my volume formula for a triangular pyramid, which is the area of the base times the lateral height divided by 3. Okay, and I actually know what this volume is. It's 180, so I'm going to write that in. And then I also know what my height is, right? So I'm going to erase that h, and I'm going to write in 12, because I know my height is 12 of this triangular pyramid. Okay, so now I'm going to do a little simplifying. So I'm going to take 12 divided by 3, which is 4, and then I'm going to divide both sides by 4. And what I've just found is that the area of my base is equal to 45 centimeters squared. So like my base here, that blue that I just highlighted, that base is equal to 45 centimeters squared. But we also know that this base is a triangle. So we can use the triangle formula, 1/2 times base times height. We can plug in 45 for the capital B. We can plug in the height. We know that height is 6. And then we can use that to find my base, my lowercase b. So we're going to use 45 is equal to, so 1/2 times 6 is 3. And then we divide both sides by 3. We end up finding that 15 is equal to my base, or x would be 15 centimeters in this case. All right, so for this one, we have a sealed rectangular container, which is 6 by 12 by 15. So that's located on the right over here. I just put a red star by it. It's sitting on its smallest face. It's filled with water up to 5 centimeters from the top. So notice how I'm drawing on my image here that 5 centimeters from the top, my water is sitting. Okay, so you can kind of consider this water as kind of like an edge, if you will. Okay, so if the whole thing is 15, so if this whole thing is 15 and 5 centimeters of it is from the top, that means the rest of this is 10. So the volume of the water is the area of the base times the lateral height. So in this case, my base is 6 by 12 and my height is 10. So the volume is going to equal 6 times 12 times 10, or 720 cubic centimeters. So the volume of the water is 720 cubic centimeters, okay? And then the next question is like, hey, what's the height of the water from the bottom of the container if we tipped it on the side? So we're looking now for this height. So we're looking for like the distance from here to here. So I'm going to call that x, okay? So if I know what the volume of this container is, I know that the volume is 720, and I know that the volume of a prism is the area of the base times the lateral height. Well, I'm just going to plug in some of these information I know. So my base is just going to be 12 by 15. So 720 is equal to 12 times 15. And then I'm just going to solve for h. So I'm going to do 12 times 15 first. So 12 times 15 is equal to 180. So 720 is equal to 180 times h. I'll divide both sides by 180. I'll end up finding that my height is 720 divided by 180, which is going to end up giving me 4 as my height.